In this video, we'll learn how to solve linear equations in one variable. You must have seen a beam balance. A beam balance is balanced when there are equal weights on its two sides. Let us consider a beam balance with 10 kgs on the left side and 10 kgs on the right side. Clearly, the beam balance will be balanced because there are equal weights on the two sides. Now let us put an additional 2 kg weight on the left side so that there are 12 kgs on the left side and 10 kgs on the right side. What do you think will happen? Yes, the beam balance will no longer be balanced and its left side will go down. To balance the beam balance again, we need to put a 2 kg weight on the right side as well. Similarly, if we remove 5 kgs from the left side of the beam balance, we will need to remove 5 kgs from the right side as well to keep the beam balance balanced. So whatever weight we add or remove from one side of a balanced beam balance, we need to add or remove an equal amount of weight to or from the other side to keep the beam balance balanced. An equation is like a balanced beam balance with its two sides, LHS and RHS. The equality sign denotes the balance between the LHS and the RHS. Whatever mathematical operation we perform on one side of the equation, with whatever number or term, we need to perform the same operation on the other side of the equation with the same number or term for the balance or equality to hold. Meaning to say that if I add any number, say 2, to the left side of an equation, I need to add 2 to the right hand side of the equation 2 for the equality to hold. If I subtract any numbers, say 5, from the left side of the equation, I need to subtract 5 from the right hand side of the equation 2 for the equality to hold. If I multiply the left hand side of the equation by any number, say 4, I need to multiply the right hand side of the equation by 4 as well for the equality to hold. If I divide the left hand side of the equation by any number, say 3, I need to divide the right hand side of the equation by 3 as well for the equality to hold. If I square the left hand side of the equation, I need to square the right hand side of the equation as well for the equality to hold. The same applies to other mathematical operations too. When we solve any equation, our objective should be to reach the final answer as x equal to some number where x is the variable. To reach this final answer, we need to isolate the variable on one side of the equation using what we have just learned in this video. To make things clearer, let us solve the equation x plus 7 equal to 8. To isolate x on one side, we need to remove the number 7 from the LHS. So in the first step, we need to think what operation and with what number should be performed on the LHS so that the number 7 vanishes from there. From the equation, we notice that the number 7 is added to x on the LHS. Therefore, if we subtract 7 from the LHS, our purpose will be served. But remember, whatever we do to the LHS, we need to do to the RHS too. Therefore, if we subtract 7 from the LHS, we have to subtract 7 from the RHS as well. So, x plus 7 minus 7 equal to 8 minus 7. Plus 7 and minus 7 cancel each other out. 8 minus 7 is equal to 1. Therefore, x equal to 1. So x equal to 1 is the solution of the given equation. You can verify your answer by checking if x equal to 1 satisfies the given equation. If you remember, in part 1 video of this chapter, we have already learned how to check if some value of the variable satisfies a given equation. Let us now solve a slightly more complicated equation. 3x plus 5 equal to 11. Our objective is again to isolate x, so we need to remove the constants 3 and 5 from the LHS. There are two ways to go about this. A, we can remove 5 first, or B, we can remove 3 first. Let us go for the first option, in which we choose to remove 5 first. Given equation is 3x plus 5 equal to 11. What should we do to the LHS so that the number 5 vanishes from there? Since 5 is added to the LHS, we need to subtract 5 from the LHS. This means we will have to subtract 5 from the RHS as well. So let's do it. 3x plus 5 minus 5 equal to 11 minus 5. Plus 5 and minus 5 cancel each other out. 11 minus 5 is equal to 6. Therefore, 3x equal to 6. Now we need to remove the number 3 from the LHS to isolate x completely. Since 3 is multiplied to x on the LHS, if we divide LHS by 3, it will vanish and we will succeed in isolating x completely. Remember, we will need to divide RHS by 3 as well. So here we go. 3x divided by 3 equal to 6 divided by 3. 3 and 3 cancel each other out. 6 cancels with 3 2 times. Therefore, x equal to 2. So x equal to 2 is a solution of the given equation. Let us now work out the second option and see if we get the right answer. In this option, we have chosen to remove 3 first. Given equation is 3x plus 5 equal to 11. Since 3 is multiplied to x in the term 3x, we have to divide 3x by 3 to remove it. But we can't divide just one term on the LHS by 3. We have to divide the entire LHS by 3. And since we are dividing LHS by 3, we will also have to divide the RHS by 3. Let's see what we get. 3x plus 5 divided by 3 equal to 11 by 3. Dividing both sides by 3, or 3x by 3 plus 5 by 3 equal to 11 by 3. Using the basics of fractions, 3 and 3 cancel each other out. Therefore, x plus 5 by 3 equal to 11 by 3. Now to isolate x, we need to remove 5 by 3 from the LHS. And to do that, we will have to subtract 5 by 3 from the LHS. We already know that if we subtract 5 by 3 from the LHS, we will need to do the same from the RHS. So, x plus 5 by 3 minus 5 by 3 equal to 11 by 3 minus 5 by 3. Plus 5 by 3 and minus 5 by 3 cancel each other out, giving us x equal to 11 by 3 minus 5 by 3 equal to 11 minus 5 by 3 equal to 11 minus 5 is 6, so it will be 6 by 3 equal to 2. So x equal to 2 is the solution of the given equation. Notice that we got the same answer in both the methods. So if you have your basics correct, you'll always reach the right answer. However, I prefer the first option because it is simpler and quicker. Let us revisit the equation x plus 7 equal to 8. If you remember, to solve this equation, we had subtracted 7 from both sides to give x plus 7 minus 7 equal to 8 minus 7. Plus 7 and minus 7 cancelled each other out on the LHS to give x equal to 8 minus 7. If we skip this step, x plus 7 minus 7 equal to 8 minus 7 and jump directly to x equal to 8 minus 7, we can say that plus 7 on the LHS has become minus 7 on the RHS. This is exactly what happens in the transposition method. We skip one step and reach the next step directly. So in this method too, we need to isolate the variable on one side of the equation, but to do that, we transfer the numbers or terms we want to remove from one side to the other of the equation. When a number or term is transferred from one side of the equation to the other, addition becomes subtraction, subtraction becomes addition, multiplication becomes division, and division becomes multiplication. The examples that follow will help make things clearer. Let us solve equation 1, which was x plus 7 equal to 8 by transposition method. To isolate x, we need to get rid of the number 7 from the LHS. So let us transfer 7 to the RHS. Since 7 is added to the LHS, when we transfer it to the RHS, it will be subtracted from the RHS because addition becomes subtraction on transfer. So we will get x equal to 8 minus 7, or x equal to 1, which we already know is the correct answer. Let us now solve equation 2, which was 3x plus 5 equal to 11. We need to get rid of the number 5 first, so let us transfer 5 to the RHS. Since 5 is added to the LHS, when we transfer it to the RHS, it will be subtracted from the RHS because plus becomes minus on transfer. So we will get 3x equal to 11 minus 5, or 3x equal to 6. Now we need to get rid of 3. Since it is multiplied to the LHS, when we transfer it to the RHS, it will divide the RHS since multiplication becomes division on transfer. So we will get x equal to 6 divided by 3 equal to 2. Therefore, x equal to 2, which we already know is the right answer. Note that we can only transfer that term or number which is added to, or is subtracted from, or is multiplied to, or divides all the remaining terms on its side. This means that if you want to transfer 3 before 5 in equation 2, you will go wrong, because 3 is multiplied only to x and not to 5. Had the equation been 3 times x plus 5 in brackets equal to 11, then we could have transferred 3 first because 3 is multiplied to the remaining terms on the LHS. Note that in this equation we cannot transfer 5 first because it is added only to x and not to 3. There is one more point to be kept in mind. If variable exists on both sides of the equation, we first transfer all the variables to one side of the equation. For example, if the equation is 2x minus 9 equal to x minus 4. The first thing that we do is transfer x from the RHS to the LHS. So we get 2x minus 9 minus x equal to minus 4. Since x was added to the RHS, on transferring it to the LHS, it will be subtracted from the LHS. Now we transfer 9 to the RHS to give 2x minus x equal to minus 4 plus 9. 2x minus x is x, minus 4 plus 9 is plus 5, or x equal to 5. In the next video, we will solve more questions using the transposition method.
If you like what you saw, don't forget to hit the subscribe button. This is Abbyshek Chandra signing off. Take care.